is everyone doing? Hope everyone's doing well. I know it's been a little bit since I've done an actual YouTube video, but here we are. I wanted to, by the way, most importantly, hope everyone is safe, doing well, and healthy. I wanted to do, just explain a couple problems from this recent compound interest worksheet that I gave. There were some questions on it. So let's take a look right here. Okay, so these problems right here, number 9 and 10, were the most asked problems. So one thing about this right here is that they were specifically at the variables they use are different than what I use. So let me clear that up. And I said that in Google Classroom. But remember, our formula is right here. Let me get a different pen. Sorry about that. Oh, it's on. There we go. Our formula right here is going to be y equals a times 1 plus r over n to the nt power, right? All right. Their formula is slightly different than this. It's the same formula, but they use slightly different variables, I should say. So for them, y is actually a, all right? And all this means is this is just the final amount, regardless of what variable you want to use. This is the final amount right here. All right, P stands for principal. In our case, we use the term lowercase a, but in their case right here is principal. And this is, of course, as I said before, the initial amount that you're putting into the account. All right, R is still the same, right? 1 plus R over N to the NT power. Just to remind everyone, R is the rate as a decimal. And as a decimal. And N rather, is the number of times compounded. And lastly, T is, of course, the time, obviously. All right, so none of that has changed. All right, so given that, let's go ahead and do this. So if we're using their actual variables, okay, they would say, we would write this as A equals P times 1 plus R over N to the NT power. Okay, no problem. So let's take a look right here if I'm doing that. All right, so that is going to be $1,119,656.69 equals my principal, which we don't know what that is, right? So we'll just leave that as P, times 1 plus R over N. All right, so R is 2.9%. Moving that to the left, that's going to give me 0.029. Over N is 2 here, and T is 28. So N is going to equal 2, and N times T, well, right here, that's going to be 28 times 2, which is going to be 56, okay? 28 times 2 is 56, so that's going to be all to the 56 power, right? N times T. All right, so what do we do right here? You may be asking. So this is just basically algebra. What I'm going to do first of all right, if you have, I think even a Google calculator will do we'll do order of operations. First, I'm going to go and simplify inside the parentheses. So I'm going to say 1 plus 0.029 over 2, right? We simplify that, all right? And then I'm going to take that to the 56 power. There we go. If you want to do it all at once, you could. Like on a calculator like this, you could say 1 plus 0.029 over 2, and you're all taking that to the 56 power, right? Should get the same answer. Perfect. 2.2393, okay? All right, try to, you're not supposed to round until the very end of the problem, but all right, in this case right here, it's 2.2393. Another thing I could have done is just actually brought that over and then solved at the end. So regardless, right here, you're going to, we're solving for this, right? So we're dividing right here by what we just got, which was 2.393. All right, so what do we do at this point right here, right? We're going to go and take the numerator, which is $1,119,656.69. I'm going to go ahead and divide that by my previous answer. In this calculator, I can just press second answer. All right, but if you just want to put it as 2.2393, that should be fine, okay? And we get all right, we're basically, if you round this, right, okay, the 8 rounds that up to $1, right? So it's just going to be rounded to right here, 500,000. This comes out to be approximately. So $500,000, that's it, okay? So that's how you do that particular problem you're just solving. Let's try another one, all right, to make sure everyone understands this. So again, their way of using variables is A, which is this is the final amount, equals P, which is the principal or initial amount, you can call that, times 1 plus R over N to the NT power, okay? So their A here is 211.63 equals the principal, we're just going to call P, times 1 plus R over N to the NT power, right? And we're going to go and fill this in. Principal we don't know. R is 1%, so that's going to be, that's going to be 2 to the left, 0.01. Okay, N in this case is 12 and T is 75. So for N right here, we're going to put 12. And T is 75, so the NT power, that's going to be right there to the 75 times 12 power. All right, that's going to give me right there 900, okay? So that's going to give me right here, I'm going to say right here, 211.63 equals P times 1 plus 0.01 to the 12th power. I mean, it's 0.01 over 12, all to the 900 power. And the 900 was N times T, 12 times 75. Okay? All right, so let's go ahead and do this. So if I'm solving right here, right, what I would first do, let me move this guy up here, is I would divide both sides by 1 plus 0.01 over 12 to the 900th power. Now, technically, you're not really supposed to round to the end, so let's just go and divide by this right here so we can get a super accurate answer. All right, that's gone. So right here we have 211.63 divided by 1 plus 0.01 over 12 to the 900th power. Okay, so let's do that. So if you have a calculator like this, you could actually just say 211.63 divided by, make sure you put parentheses here, right, or else it will not do it correctly, 1 plus 0.01 over 12. All right, close it up. And that's to the, raise that to the 900th power. There we go. That's it. 99.998. Well, what does that round to? The 8 rounds that actually to 00, which will round this up to 100. So the answer is actually just going to be $100. Okay. So the principal in this case, P, is going to equal $100. That's it. All right, a little confusing, but not that bad. Okay, you're just dividing. Now, if this way makes you uncomfortable, you could have just simplified 1 plus 0.01 over 12 to the 900th, gotten that answer, rounded it to, like, as much as you can, 4 decimals, and then divide that. You would have gotten an answer very close to 100. All right, so let's see here. Let's look at another one. So right here we have an initial deposit of $5,000 is made into a savings account that compounds 7.1% interest annually. How much is in the account at the end of 5 years? Okay, So going back to, I mean, you can use whatever variables you want. I'm just going to use how we initially did it, right? Which was y equals a times 1 plus r over n to the nt power, right? So the initial deposit right here is $5,000. Being the same account, it compounds 7.1% interest, so our r is 0.071, right? Because we're moving at 2 to the left. And it's annually, right? And it compounds annually. So in this case, if n equals 1, that means it's going to be a non-factor, and you can just ignore n, right? R over 1 to the 1 times t power. Really, that means that if n's 1, you can just ignore it. All right, and right here, time, of course, it says 5 years here, so we'll say t equals 5. All right, so let's do it. So y equals a, which is 5,000 times 1 plus. Now, again, we don't need the n here because n is 1, right? So we're just going to say r is 0.071 to the t power. T is 5, right? All right, so nice and easy here. So we'll just go ahead and on our calculator. By the way, I did give the link to this calculator simulator if you want to use it. It's 5,000 times 1 plus 0.071, which is just 1.071, right? To the 5th power, right? But you can just put it all in right there. That's right here, 7,045.589 rounds that up to 0.59. So it's 7,045.59. So at $7,045.59. Okay. All right. So I'm just trying to look right here if there's any other questions that you may have had that might be beneficial for me to go over. How about number 14? How much would need to be deposited into an account earning 4.7% compounded quarterly so that the balance will be $1 million in 20 years? Okay, so again, now we're going to have to figure out the principal. So we have right here, again, the formula actually I'm going to write it up above, so I have more room. So the formula right here is y equals a times 1 plus r over n to the nt power, right? All right, so right here, what do we know? 4.7 is the rate, so the rate is 0.047. Compounded quarterly, n equals 4. All right, the balance will be $1 million. So our balance is our final amount, whatever you called that, A or Y right there. It's going to be 1 million. And finally, the T, of course, is 20 years. So let's fill it all in and see if we can solve for this, right? So right here, Y is 1 million. Okay, equals A, we don't know. It says how much we need to be deposited. So A is unknown in this case, right? And the another formula, they call that P, but same thing, the initial amount, right? 1 plus R, which is 0.047, over N, which is 4, to the NT power right here. So N is 4, and T is 20. 4 times 20 is going to give me 80, so to the 80th power. All right, all good. So, all right, let's go ahead and simplify right here. So if I'm actually just solving for A, that's what I want, right? First, I would just go and divide by 1 plus 0.047 over 4 to the 80th power. This is right here. 1 plus 0.047 over 4 to the 80th power right there. Okay. All right, we can do this all at once if we have a good enough calculator, or just, you can do it step by step. Do 1,000, press the division key, parentheses, you can do it, But right here, I'm just going to say 1 million. Okay. And right there, make sure it has enough zeros. It should be 6 zeros, right? Divided by, right here, and put parentheses, right? We're going to say 1 plus 0.047 divided by 4. Okay. And then that's all to the right here 80th power. And this should give me the answer right here. That's going to be right here 392,774. And right here we're talking about 20 rounds to 0.20, so 20 cents. Sorry, it's not a very good 7, is it? There's a 7 right there. There's a dollar sign right there. All right, and there's our answer. All right. If you found this any way confusing, right? If what you could do is you could just simplify 1 plus 0.047 over 4 to the 80th. Get that, and then get that and divide by that actual value, 1 million divided by what you actually get from that. In like 2 separate steps, just round to like 4 decimals so it's really accurate. But anyway, that is it right there. All right. So if it says, what is the balance of our account now, they're asking for the final amount at the end. That's the easier ones. If they're asking, well, what would need to be deposited, they're asking for the initial amount, which is A. Okay. All right. All good, guys. Let's see. I think we are pretty good with this video. It's going on 16 minutes. Hope all is well. Have a good day. See you.